Hey everybody, my name is Mickey Boxell. I'm part of the Oracle Cloud Native Labs team, and I'm going to be presenting on the open source observability toolkit on Oracle Cloud. The cool thing about this presentation is that these tools don't just work on Oracle Cloud, they work on all Kubernetes providers. So feel free to take this information and apply it to wherever you normally use Kubernetes. So to begin with, who am I? My name is Mickey. I'm a solution architect, a developer advocate. There are a lot of different hats that I wear at Oracle. And I'm part of a team that builds customer deployable cloud native and container native solutions. The idea is that we're trying to bridge the gap between the feature set that OCI currently has, that's Oracle Cloud, and what our customers are expecting. And we're doing so by means of open source projects. So for context, why is this approach to observability and monitoring different from past ones? Well, in the past, people weren't using microservices in the way they are today. Now, with microservice environments, we're looking at environments that are distributed. They're often container-based, they're polyglot, so it's not all one application language. They're also highly scalable and highly ephemeral. If you're looking at a pod, that pod may exist one moment and not exist the next. And with this new architecture model, you actually have new challenges as well. So in addition to trying to figure out how to install an agent on a pod that may only exist for a few minutes or a few days, you also have to be concerned about latency between all these different components. You have to make sure those components work together, so integration testing becomes hugely important. There's also challenges pinpointing issues. So when your application is not a monolith, when it's deployed as a bunch of distributed microservices, you have to figure out in which microservice there's actually an issue occurring. It's not just one log for your entire app. There might be logs for bits and pieces that are all connected. And that makes things like root cause analyses a lot harder. So one approach for solving these issues is observability. What is observability? It's the approach of designing and operating a more visible system. We have to acknowledge that all systems are going to experience failure at some time or another, which means that you have to anticipate that and prepare for it in any way you possibly can. You also have to make sure that you can test your system in a realistic way. Someone earlier today presented, and they were talking about how a backup for a system is not really a backup until you've actually tested the recovery operation. Until that point, you don't realize that it actually is going to work. Additionally, you need to be able to monitor all of your external outputs, and I'll talk about what those are in the next slide. And I think an important consideration people often forget is what is the business impact of this downtime or the issues you might face. It doesn't just impact your developers when something stops working. It's going to impact your customer relationships and all aspects of the business. So people have to prepare and anticipate for that. So what are those external outputs that I mentioned before? Typically, people consider three types. The first one is logs, which are just a record of an event that took place at a given time. There's also metrics, which are a numeric aggregation of data describing a component or service. And then also traces, which is basically just capturing a request flow. So each one of those different components is really helpful in understanding why your environment is behaving the way that it is. Now, there are a lot of different approaches to making sure that you make your environment as observable as possible. One of the ones that people really focus on these days is site reliability engineering. This is a process where you reliably operate systems and services at scale. It came out of Google in the early 2000s. One of the key aspects of this are SLIs, SLOs, and SLAs. So SLIs are just indicators that can indicate health in your environment. SLOs are the objectives that you set for those indicators, and SLAs are the agreements that you have tied to those indicators with your customers. Another way of saying that is that with SLIs, you're defining the metrics that matter most to your business. With SLOs, you're identifying an ideal value for those metrics. And with SLAs, you're planning your reaction in case those values aren't met. Another core concept is MTTF and also MTTR. So that's increasing the amount of time that your system stands up and avoids failure. And then also the amount of time that it takes to get that system back up and running when you do inevitably experience failure. Now, as part of my process for testing out these observability tools, we wrote a sample application using the Helidon framework. Helidon's pretty cool. It's an open source project that was written by Oracle, and it's basically just a framework for writing microservice applications in Java. This is a very simple application. All it does is just post requests. It's just a RESTful web service app. And one thing I did is made sure that it was instrumented for tracing, metrics, and also logs. And of course, it's all deployed on top of Kubernetes. One thing that's very cool about Helidon is that it'll actually spit out YAML for you when you create the application. One thing I also did, and I'll talk about this later on, I have sidecar injection enabled as well, and that comes into play when we talk about service mesh. Here's what the app looks like. I have Chrome Developer Tools open on the right side so you can see what's actually going on in the back end. It's basically just a bunch of put and guess requests. So the way the app works, all I would do is enter my name, so in this case Mickey, click enter a name, and then it'll just greet me by saying hello Mickey. And one thing I can do as well is update that greeting. I can change hello to hola if we were in Barcelona, for example, and then it'll upgrade that greeting accordingly. And for anybody who's curious about how this works or wants to see the code, I am more than happy to show you after the talk. So the first thing we'll talk about are logs. So again, logs are just a record of an event that took place at a given time. Logs are great because they've been used forever and they're supported by most application libraries. One thing to remember is that you have to be disciplined to actually put logs in your application or else you're not going to get any value from them. One thing that's also worth noting is that it's important to aggregate logs because if you don't, you might lose them. So most Kubernetes applications will get logs on standard out. But again, if they're not being scraped somewhere and then forwarded via a log forwarder to something like an Elasticsearch database, those logs are just going to disappear unless you do kubectl logs, and even then they're only going to be around for a fixed period of time. In my application, what we did is just use the Java logging classes and then also set a logging.properties configuration file. So some of the tools I'm going to talk about, FluentD is used to scrape logs and forward them. FluentD actually just recently graduated from the CNCF. What it's going to do is after it scrapes, processes, and ships those logs, it's going to ship them to the persistent data store Elasticsearch. And then we're going to use Kibana to actually visualize and query from Elasticsearch to get information about those logs. At the end of the day, there are a lot of other log collection tools and also analyses tools. So just make sure that you pick something that you can use that can actually get this information from your environment. When it comes to metrics, again, they're just a numeric aggregation of data describing behavior. They're really easy to store and model. They're all numbers, so you can run pretty basic queries off of them. They're also very scalable as well. So unlike logs, where you're going to be keeping quite a lot of data on hand, these are numbers that can be sampled without losing the quality of the data. They're very useful to understanding typical system behavior, and they're also supported by most libraries. In this case, we just chose a Java metrics class, and it's going to push data to a /metrics endpoint, which is where Prometheus scrapes it. So Prometheus is actually, it's an open source systems monitoring toolkit. It was the second project to graduate from the CNCF. And what's nice about it is it actually includes libraries to create in-process samples, to scrape data, and then to push all of it to the Prometheus database. It has its own query language, PromQL, which then you can use to actually get that data and run analyses on it. But from my experience, Prometheus is not the easiest product to use. So what people will typically do is instead of visualizing directly in the Prometheus dashboard or console, they'll instead use the tool Grafana, which is an open source data visualization tool, where you can actually aggregate that metrics data and run helpful queries on it. One thing we've also done is for Oracle Cloud customers, we have our own monitoring and telemetry data exposed. So we took that, created a data source for Grafana, so you can actually natively within Grafana create dashboards of all of the infrastructure information that's coming from OCI. And the last helpful component of metrics are that they are insanely helpful for creating alerts. So alerts are just notifications indicating a human needs to take action. The reason you'd use metrics instead of logs is because they provide a very clear indicator for when something's going wrong. And if you've ever tried to use Alert Manager in Prometheus, it's not the easiest tool to use. So I would much recommend using Grafana to create those rules instead. It'll actually create Alert Manager queries on the back end, but with its Alert Manager, you can do things like send it to PagerDuty, Slack, email, and a bunch of other sources. The last thing I'm going to talk about is more unique to the microservice environment, and it's tracing. And that is basically just capturing a request flow of causally related events, and it's in a distributed environment. This is super helpful because it provides visibility into all the requests going through that environment. Each request has its own ID, and as it goes from place to place to place or event to event, what's going to happen is metadata is going to be injected into it, and that metadata is stuff that we're going to query later on and help us understand the flow of things. We use tools like Jaeger or Zipkin, which are both done with open tracing. And so in this case, what's nice about them is since they're both built on the Open Tracing framework, it's very easy to switch between them. The last thing I'm going to talk about is service mesh. And service meshes are just configurable infrastructure for microservices. They're great to control east-west traffic in an environment. What's really nice about them is because they attach a sidecar to all of your containers. Because they inject a sidecar into all of your containers, they're really good for monitoring and controlling traffic throughout your environment. What's cool about them as well is they also really help with simplifying the aspect of getting traces from your environment. They can capture latency, retries, and failures without having to actually instrument that into your application. So all you would do is make sure that the trace headers are instrumented and the service mesh will take care of the rest. One example of a service mesh is Istio. And Istio provides out-of-the-box integrations with a lot of top-class, best-of-breed tools like the ones we talked about before. So you actually, in the Helm chart, can just specify that you want a Grafana pod provision. Prometheus will be there. You can also get Jaeger and Zipped in there as well. And one thing that's also helpful about it is this tool Kiali, which is a great way of visualizing a microservice environment. So you can see all the different components of your system as long as a sidecar is attached. So now jumping into the application itself, and now we're getting to the end game. So if anyone's getting hungry, we're almost done. What I've done here is this is our greet service application. In order to make this flow make sense, I actually ingested an amount of delay right here. You can see the times 1,000. So what that'll do is every time I make this request, a particular type of slow greeting request, it's going to take considerably longer than it would otherwise. So on the back end, instead of having a greeting that takes, let's say, a millisecond or 10 milliseconds, it's instead going to take a full second. So in this example scenario, what I've done is set an alert rule so that Grafana, if it ever goes above a single second, is going to send an alert to my Slack. And that alert's just going to say right here, please take a look at request duration times. Now imagine in this scenario that I have a particular indicator, so request duration time, an objective of making that less than a second because I want my customers to have a positive experience, and maybe I have an agreement tied to that. So in this case, I'm finding out that the alert which I set at one second of latency is being surpassed, so I need to actually jump into the Grafana dashboard. So I can see right here that at this point in time, the request was not just 1 second, but actually jumped over 2 seconds. So that's something that I definitely want to take a look at. And again, the way that I made this happen was just by instrumenting a specific type of request with latency into the application. So after I go into Grafana and compare that usual time to that momentary spike, what I can do is then jump into Jaeger and then figure out, based on the timestamp, which span that request error was coming from. So I can jump into the trace, see that the request and the error, or not error, but actually the latency, was tied to this Quickstart SE observability application, observability being the namespace and Quickstart SE being the container name. I can take that information and also the timestamp, and then in Kibana, I can use those as queries. So I can basically filter based on container name equals Quickstart SE, because I know that's where the latency was taking place, and namespace is observability. And then I can take a look at a log related to that specific request. So in this case here, I can go down, I can see my log, and my log is actually, you made this request slow on purpose because I created that particular type of slow request. So of course, this is an extremely simple example of a workflow like this, but you can see how it would apply to more of a production grade environment. And the nice thing is, as soon as I stop doing those curl commands that are going to be slowly greeting my application, the alert goes away, and then I can see that my request duration alert is gone, and now it's been set to OK. So some key takeaways: observability takes a very holistic approach to operations. It's not just about what the impact is to your business from a development angle, but it's the impact to your customers and the impact to the business as a whole. The practices we talked about today give you maximum visibility into the behavior of a distributed system. And we do so by means of logging, metrics collection, and also tracing, which allow us to discover issues, pinpoint the location of the issues, and then address them accordingly. All right, thank you.